Steve Jeffords is an atomic scientist and master timekeeper.
We all, I think, have some innate feeling that we understand time. It flows past us. Time goes on. We get older. Things that happened yesterday are not happening today, etc. But I don't think that any of us, whether we're physicists who study time or just somebody who lives his life, really truly understands time.
Steve works at the National Institute of Standards and Technology in Boulder, Colorado. It's one of 6 labs around the world that calculate coordinated universal time, the official world time. This table full of lasers is the NIST F1 cesium fountain atomic clock. Measuring the nuclear vibrations of atoms, this clock ticks at 9 billion times per second. That's 1/10,000,000th of a nanosecond.
This clock will measure frequency or time interval out to almost 16 digits. Why is that important? The reasons to measure time or frequency this accurately, boy, there are a bunch of them. Some of them are scientific, but some of them are really practical. Systems like the global positioning system, the GPS system, it's fundamentally a timekeeping system. And so what we do is we put atomic clocks on satellites, make sure they're all synchronized, and now I stand on the surface of the Earth with my GPS receiver, and it gets time signals from each of these satellites, and it just measures the arrival times. And so if the signal from that satellite arrives 5 nanoseconds before the signal from that satellite, it says, oh, I must be 5 feet further from that satellite than that satellite. So it does that with 4 satellites, and it computes your X and Y position and your altitude, and now you've got your position from time. And the fact that this works at all is just remarkable, but it absolutely depends on having time at the nanosecond level, because if you don't have time at the nanosecond level, then you can't